Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.43. While solving this problem, we will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. We also will be using Ohm's law. According to Ohm's law, voltage across any resistance R is always equal to the product of current through that resistance and the value of resistance. Electrical power calculation formula will also be utilized in this problem. Power calculation formula is P equal to V multiplied by I, where V is voltage across an element and I is current through that element. Now move towards the problem. Exercise problem number 2.43. Find power absorbed by dependent voltage source in given below figure. This is the circuit diagram of given problem. We have to find power absorbed by this dependent voltage source. In order to calculate the power of this dependent voltage source, we should have at least two parameters. One is voltage across this dependent voltage source and other one is current through this dependent voltage source. Right now we don't have both values. Voltage across this dependent voltage source is depending upon the value of Vx, and Vx is voltage between these 2 points inside the circuit. So first we have to calculate the value of voltage between these 2 points labeled as Vx in order to calculate voltage across this dependent voltage source. And we also have to find the value of current through this dependent voltage source that will be equal to the current of this series network. So we will use Kirchoff's voltage law to solve this problem because this is a closed loop circuit and the value of voltage as well as current is required. In this circuit, first we will try to find out the value of voltage Vx. For that purpose, we will apply Kirchoff's voltage law inside this semi-closed loop. Before applying Kirchoff's voltage law, first we have to identify the current inside this semi-closed loop with its direction. I am assuming the direction of current counterclockwise. You may take clockwise as well. Now, according to the assumed direction of current, make polarity notations across resistive elements. We will use passive sign convention theory. According to passive sign convention theory, current entering terminals are taken with positive sign and current leaving terminals are taken with negative sign. Polarity of voltage Vx was not provided in the question, but there is an hint inside the circuit. The voltage Vx is taken with respect to this point from this point, which is showing that this point would be on higher potential than this point. But again, this is an assumption. We are taking the polarity of voltage Vx according to the previous element polarity. In this case, on this point, the previous element is voltage source and voltage source have negative terminal on this point. This same negative polarity will be appearing across this point as well. On this point, the previous element is resistance and resistance have positive terminal on this point. So, positive sign will be appear across Vx on this point. Now, write KVL equation for this semi-closed loop. Start from this 2 kilo ohm resistance. Current entering terminal is positive. So, voltage across this 2 kilo ohm resistance, that is the product of current I and the value of resistance, will be taken with positive sign, plus I multiplied by 2k. Next is voltage source. Current entering terminal is positive, so 10 volt will be taken with positive sign. Next is voltage Vx and current entering terminal is negative, so Vx will be taken with minus sign. And last element is resistance. Current entering terminal is positive, so the product of I and 3k will be taken with positive sign. Now solve this equation. Place minus Vx on the other hand side of equal to make it positive and take the products of these two values. 2ki plus 10 plus 3ki equal to Vx. Now add these together, 2ki and 3ki, it will become 5ki plus 10 equal to Vx. We cannot further solve this equation because it includes two variables. One is I and other one is Vx. So right now we will leave it as it is and move to the next step. Now we will apply KVL inside this closed loop. For that purpose we have to assume the direction of current. We will take this same current I is flowing in counterclockwise through this closed loop. So according to the direction of current I, make polarity notations across these resistive elements. Current entering terminals will be taken with positive sign and current leaving terminals will be taken with negative sign. Now write KVL equation for this closed loop. Start from 2 kilo ohm resistance. Current entering terminal is positive, so voltage across this 2 kilo ohm resistance, that is the product of current I and 2 kilo ohm, will be taken with positive sign. Next is voltage source. Current entering terminal is positive, so 10 volt will be taken with positive sign. Next is 5 kilo ohm resistance. Voltage across this 5 kilo ohm resistance, that is the product of I and 5K, will be taken with positive sign because current entering terminal is positive. Next is dependent voltage source. Current entering terminal is negative, so voltage across this dependent source, that is labeled as 2Vx, will be taken with minus sign. Next is 10 kilo ohm resistance. Current entering terminal is positive, so voltage across this 10 kilo ohm resistance, that is the product of I and 10K, will be taken with positive sign. Next is 20 volt source. Current entering terminal is positive, so 20 volt will be taken with positive sign. And last one is 10 kilo ohm resistance. Current entering terminal is positive, so voltage across this 10 kilo ohm resistance, that is the product of I and 10K, will be taken with positive sign, and all of these are equal to 0. Now solve this equation. Take the products of all these currents and resistance values. The equation will become 2Ki plus 10 plus 5Ki minus 2Vx plus 10Ki plus 20 plus 10Ki equal to 0. Inside this equation, add all values that includes variable I together and constants together. The equation will become minus 2Vx plus 30, the sum of 10 and 20, and plus 27Ki equal to 0. 27 is the sum of all these values that includes variable I. Now inside this equation we should have only one variable to calculate its value. Right now this equation includes two variables. So we will replace Vx with its value that includes variable I. By replacing the value of Vx, we will have only one variable inside this equation, that is I, and we are interested to calculate its value. So replace Vx with its value. The equation will become minus 2 into 5Ki plus 10 plus 30 plus 27Ki equal to 0. Now solve this equation. Open these brackets. Minus 2 will multiply with 5Ki. It will become minus 10Ki minus 20 plus 30 plus 27Ki equal to 0. Now inside this equation we only have one variable, so we can calculate its value. Subtract 20 from 30, it will become 10, and subtract 10Ki from 27Ki, it will become 17Ki. Place this 10 on the other hand side of equal. The equation will become 17Ki equal to minus 10. Now divide on both sides with 17K to calculate the value of I, that will become minus 588.2 microampere. Here minus sign along with the value of current I is indicating that we have assumed the wrong direction of current inside this circuit. If you have assumed the direction of current clockwise, then you will not have minus sign here with the value of current I. Now we have calculated the value of current I, we can calculate the value of Vx. So place the value of current I inside this equation. 5K into minus 588.2 microampere plus 10 equal to Vx. Open these brackets and multiply 5K with minus 588.2 microampere. The equation will become minus 2.94 plus 10 equal to Vx, and subtract minus 2.94 from 10, the value of Vx will become 7.059 volt. We have calculated the value of voltage Vx, so we can calculate the value of voltage across this dependent voltage source, that is the twice of Vx. So the value of this dependent voltage source will become 2Vx. Value of Vx is 7.059. So the value of this dependent voltage source will become 14.118 volt. We have calculated the voltage across this dependent voltage source. Current through this dependent voltage source, that is I, is already calculated in previous step. So we can calculate the power of this dependent voltage source by using power basic formula, that is the product of V and I. Voltage across this dependent voltage source is 14.118 and current through it is minus 588.2 microampere. But this current is entering from negative terminal of this dependent voltage source. That's why this current is taken with minus sign. Open these brackets, minus outside will multiply minus inside value, it will become plus, and the product of 588.2 microampere and 14.118 will become 8.30 milliwatt. And because of positive sign, this power is being absorbed by this dependent voltage source. So this was exercise problem number 2.43. Thank you. See you again in next video.